So the first function we want to modify is the evaluate function. So first we want to store our target output, which we use A as our target output, and then call the feedforward function to store our target output. And then the same, we create a NumPy array for our YD output, so we can use that later in our formula. And then we have the number of the count, which is the length of the test results. And then we have our correct count, which already have in the code. And then we want to calculate the accuracy, MSE, cross entropy, log likelihood, as we can find from our book. And we use the formula to create these functions here. And then we want to store all the 5 results: correct count, accuracy, MSE, cross entropy, and log likelihood in a list. And then we want to return the 5 results list. And back to our second modification, which is our SGD function. So we want to first collect all the training data and the test results in a list. So we create a results list, and then we want to store all the training and test results in this results list. And the first thing is we call the evaluate for training data, and then we want to print the epoch, the training MSE, training and test MSE, cross entropy, log likelihood, and correct number and accuracy. So this is how we print the training. And then we want to append the value in the results list so we can collect the training evaluate results. And then we want to print the same as the training, so we do the test data, so we can print the test results. And then we want to, from the application results, we want to append an empty list. And then we want to, the last thing we want to do is to stop when the classification accuracy for the training data became 100%. Then we want to stop, which use break, and then we want to return to an individual list. And the third thing we want to do for the modification is for our backprop function. So the first thing we want to do is create a list to store all the Z factors layer by layer. And then second, we want to initialize the local variables, which is the activations allocated with a structure which can hold the activation value all layers from the start. So that's why we create the NumPy ND arrays of the shape n and 1. And then we write a for loop. So if the layer is the input layer, we return the activations equal to X. And else, when we check the previous code, we have the Z equal to NumPy dot weights activation and plus the bias. So we make a little bit modification. So we have this, we update this value, and then we append the update value to the list. And then we can update our structure, the activations have the sigmoid value here. And then we, so because in the application, we want to comment out for the print activations, but before we will have this, so we will print our activation values here. But now we just comment it out.